See if this is what you did.
We'll see.
We can't see what you're seeing because your hand's in the way, but
Oh, sorry.
all right.
You see that this is 1/4 right here. If you divide it into 4 pieces, into one square. And then the same thing here. If you divide it into 4, it'll be 3/4. And then another 4th here. Half. 3/4. And then you add them together. Your total.
What is the total?
I haven't gotten there yet.
Oh,
So, someone want to add it?
do we care about the total?
It's 3. Okay, it's 3.
It's 3. Anybody agree with that?
Yeah.
Okay. Okay, that may not be how you did it.
Because
Number 7, I need somebody to talk about 7. Who can do 7? I'm going to come and do 7.
So what I did first is I connected all the dots to kind of help me see. And then I brought this one down to here. And I brought this one up. Let's see where that is. Here. So that left me with 1, 2, 3. And this one's a half, so 3.5.
So she actually cut pieces off and put it on other places to fill up the gap. Okay? Let's see. Did anybody use a subtraction strategy? Does anybody know what I'm talking about?
Yeah.
I think so. But let me share with you what I'm talking about. I'm on number 4. Now you're saying 4 is easy. Well, just watch the strategy, because the strategy I'm going to show you on 4 might work better on another one. Rather than trying to find out what's inside, I'm going to surround the entire thing and make it a rectangle. Since rectangles are nice, that's 2 by 3, so the whole thing is 6. However, this part isn't in my figure, so I've got to subtract that out. How much is it? A half. There's another half, so I'm going to subtract out a whole, plus this other whole that's there, so I'm going to take out 2. Does everybody see that? 1 plus the 2 halves is a whole. 6 minus 2 should be 4. Did you get 4 for that one?
Yes, sir.
Now, sometimes that just surround your figure by a rectangle and then subtract out the pieces that aren't really part of your figure to get your... Does that strategy make sense? Okay? All right. You're going to be doing a bunch of this in the homework and in class on Tuesday, so you need to get pretty good at it. How many of you feel like you're getting better already? Yeah, especially as you talk. I'm hearing you talk and sharing different strategies, and this is great. Okay. We're going to change gears again. You need to pull out the round object that you brought from home. Okay? Every person needs to pull out a round object that they brought from home. Who brought the biggest object? We got anything like this or CD? Anything bigger than a CD? Ooh, frisbee, plate. Okay, good. Let's give you these longest. Let's see. What I need you to do is, I suggest that you work with a partner because sometimes you need more than two hands. I want you to do two things. Take your circular object and using your ruler, go right across the middle and find the what? All the way across is diameter. So I need you to find the diameter, and then I need you to find out the circumference. Okay? So the way you'll do that is you might get a piece of string and have two or three, you might even get two partners and have them hold the string around the outside of your object so that it's, and then take the two ends and then hold it up and measure it against your ruler. If you need a ruler longer than a 12-inch, we've got some meters. Some of those larger ones you might need. If you try doing this alone, your accuracy is going to be less than what it should be, and we need it to be as accurate as possible. So if you have something, get 2 or 3 or 4 people helping you with multi-sets of hands, and then you help them with theirs. Anybody notice anything?
It's close to pi.
You what?
What? I said it's all close to pi.
It's all close to what number? Close, just barely over 3 is what they all should be, right? Yep. The closer you got to 3.14159, the more accurate your measurement was. Okay? Now, we have C divided by D is equal to pi. That's what we have, right? Let's do a little bit of algebra. How could I get C alone? Multiply both sides by D. And what happens here? I get C is equal to pi D. So the circumference of a circle is equal to pi times the diameter. But we've learned that a diameter is just 2 r's. So I could say 2 pi r or pi r2 or we can put whatever order is the same, right? Let's add this to our list of formulas. Now, pi is not a number that someone invented to torment 206 students. Pi is a number that was discovered and has been known for thousands of years, to the point where I'm going to show you that it can even be found in the Bible. They knew about it thousands of years ago. Okay? I am in the book of 1 Kings. I am in chapter 7. And I am in verse 23. Can I get someone to read that, please?
Verse 23.
It's highlighted. Maybe I shouldn't highlight it. Is that better? Okay.
And he made a molten sea 10 cubits from one brim to the other. It was round all about, and his height was 5 cubits, and a line of 30 cubits did compass it round about.
Okay, so it's a molten sea, and what shape?
Round.
Round. It says round all about, right? And what about it?
10 cubits from one birth to the
10 cubits from one brim to the other. That's a what? Diameter. And it was what? 5 cubits high. Well,
So hey, look, that's radius.
that means this is a three-dimensional thing. But what was the distance
30 cubits.
around? 30 was our, so if we take 30 and divide it by 10, we get 3. That's really close to what most of you got, right? By the way, if we do a three-dimensional diagram, it looks like this. Anybody know what this is?
Cylinder.
The question is,
What's happening right here? Keep reading. Keep reading down here. 25. And it stood upon 12 oxen, 3 looking north, and 3 looking toward the west, and 3 looking toward the south. What? It's the baptismal font in Solomon's temple. And Solomon knew back then his measurements still bear out what we know about pi. Okay. We have run out of time. I need you to either cut out and duplicate, or cut out and cut up and rearrange trapezoid to get it into actually a triangle, a parallelogram, or a rectangle, because we can take any of these back to Mama now, right? So turn it into anything we've already got and see if you can come up with your formula for it. Have we got it?